over 22. So that would be our answer. So we can box it up, make it nice and clear, but this is the answer for B, where the first sock isn't replaced. Okay, C. So C is asking for the probability of selecting a yellow and a yellow, the same thing, but this time round, if the first pick is replaced. So this does change things. So the first yellow probability of pulling out that yellow is 3 out of 12. Now, the second time round, it's not 2 over 11 as it is above, because the first sock was put back in the drawer. So there would still be 3 yellows in there, and there would still be 12 total in there. Again, this says and, so that means we need to multiply these probabilities. So 3 times 3 gives us 9, and 12 12s are 144. So that is our answer. 9 divided by 144, 9 over 144. And if we simplified this, we could in fact divide by 9 and divide by 9, and that would give us 1 over 16. So this would be our answer in this case. So as you can see, if the first sock is replaced, there's a much higher chance 1 out of 16 is a bigger fraction than 1 out of 22. So if the yellow sock is replaced, if that first sock is replaced, there is a much greater chance of selecting 2 yellows in a row. Okay, that was number 6. Okay, so question 7 is asking about LCM, GCF, and also PF, prime factorization. Question 7A is about LCM of 6, 8. So these are multiples, so what we need to do is we need to find the multiples of each of these numbers. Because it's least common multiple, when I think multiple, I think multiply. So I do 6 times 1, 6. 6 times 2 is 12. 6 times 3 is 18, and 6 times 4 is 24. And we could keep going, we just don't need to. For 8, the multiples, 8 times 1 is 8. 8 times 2 is 16. 8 times 3, 24. And so on. So what we can see here is that a couple of the numbers, well, 2 numbers there are the same. 24 appears twice. These are common. So these 2 that I've circled are common multiples. We need to make sure they are the least, meaning smallest, and they are. If we kept going, we would also see other numbers that were the same. So for this one, the LCM, the least common multiple, is 24. It appears twice, once in each line. All right. So then the next one, GCF, we are asked for the GCF of 15 and also 30. So if I list out the factors of 15, so factors are different to multiples because factors are parts of the number, whereas multiples are 1 times that part, 2 times that part, and so on. So the factors are generally smaller and the multiples are generally bigger. So the factors of 15, well, 1 times 15 gives you 15, so 1's a factor, so is 15. We could also do 3 times 5. 3 is a factor, 5 is a factor. So these are the factors of 15. We can't really think of anything else that are whole numbers. If we were to do 2, it would be 2 times 7.5. So that's not going to work for factors which are whole numbers. Okay, next we've got to find the factors of 30. So we could do 1 times 30. We could do 2 times 15. We could also do 3 times 10. And we are also missing 2 as well. We could also, I don't have enough room, but really I should have also put 5 times 6. So these are all of the factors of 30. So make sure we remember that 5 and 6 can also fit in there. Okay, so now we need to do a very similar thing where we look for the common factors. So we need the factors that appear in both. Well, 1 is a common factor. It's in both of them. 5 is a common factor. It's in both of them. Also 3, almost missed it. 3 is a common factor. And 15 is also a common factor. So with these two numbers, there's lots of common factors, but we need the greatest, the biggest common factor. And so in our list, the greatest, the biggest number we circled is 15. So therefore, this is our answer for the greatest common factor. Okay, next we are asked for the prime factorization of 300. So there are a few ways to do this, but the way that I would probably do it, first of all, is to try and think of the biggest numbers that I know go into them. Well, there is bigger, but I would probably split it up into 30 and 10. And we need to keep thinking of which two numbers multiply to give you the number above. So here we've got 30, but we need two numbers that multiply to give you that. So we could do 6 and 5. 6 times 5 give you that 30. 5 is a prime number, so we're at the end of that branch. 6 can split to 3 and 2. 3's prime, 2's prime, we're done. We now need to go back to 10. So we've got 2 times 5. Now these two are both prime. So these two prime numbers here, if we multiply them, do give us the 10. So everything has a circle on it. These are all prime. So our answer is 2 times 2. Let's make that look like a 2. 2 times 2. So that's this 2, that 2. Times 3 times 5. Times 3 times 5. And also the other 5 times 5. So I'm putting them in size order, and to write these in exponential form, I could write it as 2 squared times 3 times 5 squared. This would be our final answer for the prime factorization of 300. That was question 7. Sarah, can I follow on? Okay, question number 8. So 8 is asking us essentially about the Pythagorean theorem. We're told Brenda is convinced that a triangle with the sides, so even straight away as I'm reading this, I'm thinking I need to draw triangle. It's going to help me. Now we're not sure if this is a right triangle, so I'm not going to write the little square there. But we're told that it is 6 centimeters by 8 centimeters by 11 centimeters. And Brenda thinks this is a right triangle, and we need to prove if she is correct or not. So in this question, really we're using the formula a squared plus b squared equals c squared. In this case, it doesn't really matter about the two smaller sides, but the 11, because it's the bigger side, if this is a right triangle, that would be a hypotenuse. The 11 must go on its own. The other two, we can mix up. It doesn't matter A or B. So 8 squared plus 6 squared, and I'm going to put a little question mark. Does it equal 11 squared? So 8 squared is 64. 6 squared is 36. And we're asked if this equals 11 squared, which is 121. So again, question mark. 64 plus 36 is 100, and 100 doesn't equal 121. So therefore, we need to go back and answer this question. It says, prove if she is correct. Now, she said it was a right triangle. So we must say that because 100 does not equal 121, and the Pythagorean theorem, hopefully it's going to be neater than me writing it, doesn't work. This is not a right triangle. Alright, hopefully it won't take that long to write it as well. Okay, and if you wanted to, what some of my students do is they use 3 dots to represent therefore. Therefore. And so one of my students has just indicated this to me, that you could actually use this symbol next to your final statement. So 3 dots in the shape of a triangle means therefore. So you could say, therefore, this is not a right triangle. Excellent. So I'm just going to add up the tallies, but on the table it says Coke. Coke is 7. It also says Pepsi. Pepsi is 6. Also says Mountain Dew. Mountain Dew is 4. And finally, there's Dr. Pepper. And Dr. Pepper is 3. So we're told that these are students' favorite sodas. And what we're asked to do is to create a circle graph and also label it. Create a circle graph and label it using this data. So we need a couple of things. So the first thing that I would do next to this, if given this in the test, is to create a table. So if I just draw some lines right now, let's create a table. And in this table, I would need a couple of things. I need to find out the degrees, and I also need to find out the percents so I can label my pie chart. So first of all, I created the table, and now I'm going to write degrees. And I'm also going to write percents. Now I have this extra column here. So this extra column I would use for the fraction, because this fraction is very important to help us figure out the degrees and the percents. So we have these numbers. Let's work out the total. So the total, 3 and 4 is 7, plus 6 is 13, plus 7 is 20. And also in this question, we were told 20 people were asked this question. So if 7 out of 20 prefer Coke, that fraction is 7 out of 20. If 6 out of 20 prefer Pepsi, then that fraction is 6 out of 20, which could be simplified. We could write 3 out of 10 for that one. Mountain Dew, 4 out of 20.